That's it, Brian?
Hello, I'm Jimmy, and today I'll be building a 5-inch quad. Here I've got all the parts, all the tools, and this is my 6-inch quad. I've built it quite a while ago. It's a little bit old for now. It has an F3 board, some old parts. I want to be building something smaller, lighter, newer, faster. So I will leave this to the side for now. These are for later. So let's start. I will be building it on a 5-inch frame, the Martian 2, 220 millimeters. And the motors I'll be using are the Racer Star 2306S, the 2700 kV version, and I believe they are the most powerful that this company makes. So let's go on to the ESCs. They are from the same company. They are the RS30, they are 30 amps, and the highest protocol they can run is D-Shot 300. This is a Matic PDB. It has regulators for both 5 and 12 volts. And this is the Eachine TX801. It's a video transmitter from Eachine. It has 72 channels, switchable power from PID mode, which is 0.01 milliwatts up to 600 milliwatts. And I think the only bad thing about it is that it doesn't have smart audio. Otherwise, it's a very good versatile video transmitter. Let's move on to the flight controller. It's the Betaflight Omnibus F4 version 3 with integrated OSD. Of course, I'm gonna need a soldering iron, some solder, the antenna, and these standoffs. And this is the Foxeer Monster V2. It's a 16:9 camera, widescreen, 1200 TVL. It has a 2.5mm lens on it, and it's switchable between PAL and NTSC. From the reviews I've seen, it's a very good camera and it has a lot of options to tune it. I will be adding a buzzer to the quad in case I lose it somewhere. This is a 5-pack. This is the X6B receiver for the radio, and I will be using iBus with my FlySky. This is a pigtail for the video transmitter, which I don't know if I'll be using. I'm going to need some small zip ties, some long zip ties, some heat shrink. This is a double-sided foam tape which I will be mounting the ESCs with. Also some electrical tape, and this is the other table that I have all the tools on. So here are 2 Allen keys. One is for the frame and the other one for the motors. I also have a Phillips screwdriver for the camera, a small flathead screwdriver in case I need it, and these are some hemostats. It's the tool that everybody uses. A hex driver for the frame, and this one is for the props. I also got a spare prop which I will be cutting, and I will put the pieces on the ESCs to protect them. What else? We've got some cutters. These are the props that I will put on the quad once I'm done. Some Velcro. This is a tissue paper and a toothbrush which I will be using with alcohol to clean up some excess flux after I've done pre-tinning the PDB. I've also got a battery for the end and a checker and some straps. The Martian 2 already has one in the box, but I haven't just in case. These are some extra cables in case we need them. This is a hot glue gun, which I don't think I will be using actually. Also a multimeter, some scissors, and the wire strippers. And I think that's about it. So, let's get this started. Well, we've got the Martian 2 frame, some soft mounts that I added, I purchased them separately, a rubberized battery strap, these motor protectors that I don't think I will be using, 2 different size screws and the foam feet, the Martian 2 PDB. I will not use that either. It's a structural component though, so I will put it on the quad because it keeps everything together. I will use the Matic PDB that I mentioned before. I wish I didn't have to put it on to save some weight, but it's needed. The standoffs between the bottom and top plate, next T60 connector, and the main parts of the frame, which I usually do not file. I don't find the need for that. So, I will put it all together in fast forward. Let's go. Alright, the frame is done. It looks pretty good. Now we'll have to do some work on the PDB. I will show you a little bit about it, the pads. So these are the two pads that you connect the battery. I will use some wire obviously, and these 1, 2, 3, 4 are the pads for the ESCs. This PDB also has 4 different LED outputs, but I will not be using them, and regulators for 12 and 5 volts, but they will not be needed since we will power the camera from the output of the video transmitter. What else to be noted here? Alright, it also has a buzzer which will notify you depending on where you set the voltage. So there are 3 LEDs here, and you have 3 options. One is 3.6, 3.5 or 3.4 volts, and depending on where you set it, it will start beeping at that voltage per cell. So let's go ahead and pre-tune the PDB. Alright, the PDB looks fine. We will probably be tuning some other pads later to power the flight controller, but it's good for now. So, what's next to do is prepare the motors and the ESCs. I will be cutting their wires and tuning them as well. Let's open everything up. Alright, we have everything on the table, so it's time to measure and cut. Let's try to figure out how to mount the ESC. We'll have to measure both the wires and give them a little bit of slack, but in general I will try to put it pretty close to the frame, so the motor wires are a little bit longer. Something like that looks good, and the motor will go here. We'll measure that too. I also need to mention that from the black and white cable coming from the middle of the ESC, you're not gonna need the black cable. It's ground for the ESC signal, but you don't need that. I'm gonna cut it off. With that said, let's cut and tin the wires and also tin the ESC pads. It's the motor's turn since we're done with the ESCs, and the ones with the red nuts are gonna be spinning counterclockwise. You can see their direction from the arrows on the top, and the threads on them, as you can see here, are clockwise. So let's measure them, cut them, and tin them. all the motors are done. I've cut them to length and pricked in the wires. So what I'm gonna do next is get the PDB and connect the battery leads on it. So we need the XT60. There it is. And I'm gonna get some 14 gauge wire. And I'm kind of measuring it. Just eyeball how much you need. It has to get to the top of the stack since the battery is going on the top. Cutting it to length. And I'm going to do the usual. Strip it, pre-tin it, and connect it to the XT60. Pay close attention to the plus and minus, both on the PDB and the XT60 connector, to make sure you don't mix them up. And the PDB is ready. So what I'm going to do next is mount everything on the frame, since I have measured all the wires. So I'm going to be using this white double-sided tape. It's not exactly soft mounting the ESCs. I just want to put some kind of material between the ESC and the carbon fiber to make sure that it won't ever be in contact with it, because the carbon is conductive. So let's go ahead and do that, and right after I'm going to connect the motors to the ESCs, all wires straight, and I will reverse the two that are needed through the software. Music.
Hit that jive jack, put it in pocket till I get back. Going downtown, see a man, and I ain't got time. Shake your head. Hit that jive jack, put it in pocket till I get back. Time shake your head.
Okay, they all look fine. I have measured and cut them, so they should fit right in. So let's go ahead and do that. I'll put everything on the frame and screw the motors in and solder the ESCs to the PDB.
This world out here is lonely and cold. This world out here is so lonely and cold. This world out here is lonely and cold. Oh, I guess I'll go back home.
Remove the last one and put it in place. Okay, it looks more like a quad now. What I have to do next is connect the ESCs to the PDB. I will solder them coming from the inside to make the build a little bit cleaner and protect the cables a bit from crashes. Now let's put a piece of prop on the ESCs to protect them. Check this out. And now we'll have to work with the flight controller. Let's test the orientation and the mounting position. I mentioned before that this is an Omnibus F4 board. It's the version 3 and it has an SD card slot. As you can see here, there is an arrow which should be pointing to the front of the quad. This picture is a pinout diagram of the flight controller and I will show you where to connect everything. Let's go ahead and start with the voltage. This is where you power the flight controller from. I will connect two cables that go from the PDB, which gets VBAT, to the flight controller, and that way I will have the battery voltage and the cell voltage on the OSD. If you connect it with standard 5 volts from the PDB, all you're gonna get on the OSD is 5 volts, so that's not gonna do it. And these two pins are where you connect it. The red one, the positive, goes to VBAT and the black one goes to ground. After powering up the flight controller, I will be adding a buzzer, and it has two legs. One is longer than the other. The long one is going to go to buzz plus. The short one is going to buzz minus. I'm going to connect two little cables to the buzzer to make it easier to put it over the standoff. Right after, I will connect the cables of the 4 ESCs. I will measure them carefully and connect them to the 4 outputs, 1, 2, 3, 4, according to the Betaflight motor setup, and I will pass them under the flight controller to get a clean look. So let's do these 3 things: power the flight controller, add the buzzer, and connect the ESCs. The next thing that's going on the flight controller is the radio receiver. I'm using the X6B, which has a little bit smaller holes and my standoffs don't fit quite nice, so I have to file it. That's what I'm doing here, and right afterwards I am measuring the wires. I will cut them to length, route them under the flight controller and connect them to UART3. I have found that this port works well with the iBus of this radio receiver, so I will connect the yellow wire, which is the signal, to this pin right here. I will get the 5 volts from this pin and I will ground it to this pin. Next, I'm going to connect the video transmitter. As you can see here, there are 5 cables connected to it. 2 of them are the voltage and the ground. So I will connect the red one to the 12 volt output of the PDB since it's regulated, and then the other 3 cables are the signal, which is coming from the camera, the power and ground to power the camera. So if you want to use the camera's OSD, then you connect the yellow cable of the camera to the yellow cable of the VTX. If you want to use the Betaflight OSD, you connect on the board the cable from the camera on this pin and the cable from the VTX on this pin. That way the image from the camera goes into the flight controller, it gets the OSD, and it comes out to go to the VTX and be transmitted to you. I prefer the Betaflight OSD, and that's what I'm going to use, but I will show you both ways, starting by the camera's OSD. In that case, you will need to remove one cable, which is the green one, it is audio, and you're gonna need to solder the blue one, which is the battery voltage sensor, to the PDB where it gets exactly the same voltage as the flight controller. I'll do that after mounting the foam feet on the bottom of the arms and the purple standoffs on the quad. And that's what the cable should look like. We have directly soldered the one from the VTX with the one of the camera. I have also mounted the camera with the provided stand. I didn't use any carbon plates from the Martian 2 kit. I just screwed in the metal case of the camera to the bottom plate. Now I'm going to show you the second way, which is using the Betaflight OSD. So in order to do that, I will cut the direct solder of the yellow cable and connect them to the flight controller as I showed you before. With that complete, it seems like all the electronics are on the quad, so the only thing to do is the final assembly. It's finally ready. Last thing to do is put the antenna on the video transmitter. Do not forget that. You can fry it. And let's connect the battery, see if we get any smoke. We do not. That's great. And so let's connect it to the computer and I will explain what to do with the software. Okay, so we are here at the computer and it's time to configure the software of the quad. Just go ahead and connect it to the computer. Alright. You should have these two apps from the Chrome Web Store. They're free, just download BLHeli Configurator and Betaflight. First of all, you need to open BLHeli Configurator and select the correct USB port. Mine is COM5 and hit connect. Okay, at this point you have to connect the battery to the quad, so please take the props off. Accidents can happen really easily just from a bug or something. Do not have the USB and the battery connected to the quad at the same time. Please take the props off. So after you do that, go ahead and connect the quad. Okay, the battery is in. Go ahead and press read setup. This will read the setup of the ESCs. What you need to remember or write down is this code right here. It's the version that your ESCs will use, and everything is different for every ESC. If at some point you don't remember it and you need to flash your ESCs, you can go to the BLHeli Configurator website and you can hopefully find what you need from the brand of the ESCs and the model. So go ahead and press flash all, leave this as it is and select the version 16.65. This is what you're gonna need, and press flash. So what this will do is flash all the ESCs one after the other instead of flashing them individually. So after this is done, it should say here 16.65 underscore tones to all your ESCs, which is great, by the way, because what you can do with that is have some special tones on your ESC when you connect the battery in. What you can do with that is here the beep strength, you go to 91, 92, 93 or 94, and for these values it will play a special tone for the ESCs. I think 91 is the Darth Vader theme song and 93 is Game of Thrones theme. Well, 91 through 94 are different themes and I like them, I've tried them, they're pretty fun. I just don't want them to be so loud, so I have it at 10. Also, this is the beacon strength. The beacon is a feature that it has your ESCs play a tone if you have them idle for 5 minutes or longer. You can configure that here. You can put it less or more, or if you don't want it at all, just put infinite. If you don't have a buzzer on your quad, this could be very helpful, but I have a buzzer, so it will not be very helpful for me. It's not that it's very loud either. I have it at 200 and it's not that loud. It's not louder than my beeper. So if you can, just put a beeper on there, but if you can't, this is a nice feature to have. So after you configure everything, you need to reverse motors number 1 and number 4. So you do reversed and right setup. You press this one and you're done with BLHeli configurator pretty much. Disconnect. Okay, we can close that and we can go to Betaflight. So in Betaflight, you need to flash the firmware first. It depends what kind of flight controller you have, and you have to select that correctly. Mine is the Omnibus F4 with an SD card, so this is the right for me. It depends on what you have, so select the right one, consult the manual, and then I always use the 3.1.7 version. This is the latest stable version from 3.1 Betaflight. So go ahead and select the latest one, load firmware. It downloads it somewhere temporarily, and then flash firmware. So after this is done, it will have Betaflight flashed in your flight controller, and you can go ahead and connect it. So I will go through all these tabs. The first one is setup. The only thing you can do here is press calibrate accelerometer. Okay, it moves it a little bit, it calibrates it. That's it. Let's go to ports. Here is the port that you have connected your radio receiver. I have connected it to UART3. If you have connected it to UART1 or UART6, go ahead and turn on the right serial RX button. That is for me. Also, if you have smart audio on some other ports in one of these, go ahead and do this. Select this. I do not have smart audio, so I'm not selecting anything here. So let's go ahead and click save and reboot. Okay. Okay, here's the configuration tab. I run both my gyro and my PID loop frequency at 8 kHz because I have an F4 board and it can run it. If you have an F3 board, you have to lower that to 8 and 4 or 4 and 2. But with an F4 you shouldn't have a problem. It's a pretty fast board and it can run it. I have accelerometer on. You can turn it off if you don't want it. Here is the craft name that is gonna be shown into the Betaflight OSD. And here's the receiver information. Most people use serial-based receivers. This is what I use. If you have something older like PPM or PWM, go ahead and select that. But for the Taranis and FlySky and Spectrum, this is what you have to select. And here you have to select Spectrum, S-bus for Taranis, or I-bus for what I run. So here's other features. This is what I usually have on: telemetry, black box, SD card, OSD, and VTX. I have VBAT on because I want to see the voltage in my OSD. I do not have a current meter, so this is off. I don't have a GPS either. What I have done is I have RSSI. This is based on a mod, and I will explain it a little bit in a minute. What else? Well, if you have mounted your flight controller in some kind of way that the arrow is not pointing at the front of the copter, then you want to rotate it from here, otherwise it will confuse the pitch and roll axis. So you want to put values 90, 180 or 270. Mine is mounted fine, so I don't need to do that. I have motor stop off, and also this is the latest protocol that my ESCs can run. It's DSHOT 300. So go ahead and click save and reboot. So let's go ahead to the next tab. It's PID Tuning. I won't go into that. It's a whole nother chapter. It's a huge chapter. I can recommend 2 videos. One is from Joshua Bardwell, and he tunes the quad from FPV. It's a great guide. I will leave a link in the video description. The second one is from Stinger Swarm. It's line of sight guide. They're different. They're both great. Those two I can recommend. This is just the stock one. I'm not doing anything with it right now. So after you're done calibrating everything, just hit save, and let's go to the receiver tab. For this one, again, you have to connect the battery, so again, remove the props. So go ahead and plug in the battery. And you will see the values change as I turn on my radio. There it is. So if you have soldered everything correctly to the flight controller, this is what you should see. Roll 1000 to 2000, pitch the same, yaw the same, and throttle. Seems to be working fine. And then just try your aux channels to make sure they all work. Okay, and for auxiliary 6, I have set my RSSI signal that I told you about before. I have set it to channel 10, which counts from the beginning, not just the auxiliary channels. So channel 1, for example, is raw. So I've set it to channel 10, and this is the signal strength, which is 99% right now. I have used a mod that turns the radio into a 10 channel radio. You can do that. I will leave the GitHub link down in the description. For the stick minimum, it's the minimum value that your copter will start to accelerate. It's not the arming value. The arming value will be this one, which is the lowest point, which is 1044. Have this a little bit higher. So I think that's about it for here. Modes. Okay, here you configure your auxiliary switches. I have ARM on aux5 because I have set aux5 to be on my radio. Two different switches. I want to have a two-stage arming because it's a lot safer. With one switch you can just flip it by accident and on your quad, and a lot of stuff can go bad. So I flip one switch, it does not arm. I flip the other switch, it does not arm. I have to set both to arm it. Otherwise, you just hit aux1 and have one switch if you don't want a two-stage thing. Anti-gravity, I have set it to aux1 because I want it always on. It doesn't matter which channel I set it to, because the range is the whole thing. And then I have the modes. This is the aux2 is a three-stage switch. So this is the default one, this is the second stage, and acro is the third one. Second one I have horizon, which I really don't use. And then I have set a beeper to auxiliary 3. There it is. If you don't have a third auxiliary channel, if you just have a 6-channel radio, just set it to aux2 and have it at the same range as horizon mode, because frankly you shouldn't be using horizon mode that much. So I think that's it from here. Some people use air mode. You can turn this on and put it the same as anti-gravity, like the whole range. I don't use it. Just do what suits you best. Click save and go to the next tab, which is the motors tab. Again, you have to have the battery connected for this one, and please take your props off. So after you take them off, you can press this one and you control the throttle from the mouse. So here it was. Seems like 1024 is the minimum, so that's where my cover idles. So the 1044 in the previous tab seems fine. Okay, we can go ahead to the OSD tab and we can also disconnect the battery now. Alright, battery disconnected. So here you configure your OSD. It's however you want to see it. I run it like this. I want the logo off, and then I run the throttle position, the voltage, the RSSI value, flight time, mode, and the craft name. This is what I like to see when I fly. Mostly the voltage actually. The other stuff is just there. It's the RSSI, it helps a lot too. This can only be done the way I told you before with a 10-channel mod. So you can put it in a separate channel. I can leave a link in the video description for that too. Also for the video format, I have set it to NTSC. I've set my camera settings to be NTSC as well because it's on auto by default. I do not want it on auto. I don't want it to suddenly change and lose video. And for the units I use metric because I'm European. Another problem that you might have is that you can have a screen full of V's and the letter V everywhere. This is because you haven't uploaded a font. So you go to Font Manager and just leave it on default and hit Upload Font. So after you do that, your OSD should be fine. Next tab is, of course, click Save. Okay, next tab is the black box tab. I have the SD card version of the flight controller. I just don't have an SD card in here yet. For the frequency, you should use 1 to 1.6 kilohertz. You shouldn't use anything more because there's nothing to get from that. You're just overloading the flight controller and the processor for no reason. The stock is 1 kilohertz. If you really want some detail, go to 1.6. Do not go higher. There's no use. When you insert an SD card, you will see that it will commit 4 gigabytes of space. That, of course, is if you have inserted a bigger one. I have an 8 gigabyte one, and that's because it's formatted in FAT32 system, which can only produce a file up to 4 gigabytes. It cannot produce any more. So this is the space it will commit for the logging file, and it's huge. It's pretty big for the black box. It should last you for a very long time. For the CLI tab here, you can always put this command, set small underscore angle equals 180. Press enter and then save and enter again. Your cover should reboot, and what you just did is you can arm the quad even when it's hanging upside down. It's by default it's disabled because for safety reasons, but I always turn it on because if you're stuck on a tree and you're hanging upside down, you can try to make it fall out of the tree just by trying to arm it. Or if you have landed upside down somewhere and you can't find your quad, you can maybe try to arm it for a second and try to hear it. It's helpful. It's just a little more risky because it can arm when you have set it somewhere upside down. Anyways, okay, the last thing to check out is the failsafe. So click Enable Expert Mode and go to the failsafe tab. You should probably have this off. It's a stage 2 failsafe system. What this does is when you lose signal, this is in auto by default. So auto means that your motors will stop moving and will fall out of the sky, which is the safest way. But what I do is have the failsafe stage 2 on, and I have throttle hold. What this does is it holds the throttle at the position that it was before for half a second. This is what the 5 here means. It's 1 is for 1.1 second, so 5 times that is half a second. So this is what I put here. So it holds the throttle for half a second if I lose signal. It's not very safe, but I do not fly close to people or property, so half a second of throttle hold should not cause any serious damage. If you're flying somewhere that half a second could harm somebody, have this off. So that's it, I think. Just hit save and reboot. After that, you should be ready to fly. Please write down in the comments if you liked the way I built the quad and configured it, or if you didn't like and what I could do better in the next build. If you disliked it, you can press the dislike button, but if you liked it, hit the like button, subscribe, and maybe consider sharing this video. It would help me a lot. As always, fly safely.